Okay, sir. So, hello all participants. We are here for the last session for day, and it will be taken by Bhavin Darji sir, and it will be on introduction to Node, MCU, Arduino, Raspberry Pi, and ARM Linux. Bhavin Darji sir is embedded engineer at EduTech Learning Solutions Private Limited. He has experience of more than 5 years in working with IoT devices and embedded systems. And he has done his Masters of Engineering in Electronics and Communication from GTU. Currently, he is working on NVIDIA-based platform, and he has also worked with STM32F4 ARM Cortex M4 based kit, and he has a knowledge of ARM architecture, and his areas of interest are IoT, ARM microcontrollers, embedded GPU hardware, and its applications. So I request Bhavin sir to carry forward the session. Bhavin sir.
Hello everyone. I hope till now the sessions are going well and you guys are not bored, correct? Because from the morning, I should say from yesterday, you are hearing IoT this, IoT that. But before I start session, I just wanted to show you a simple video. I have a video which shows what IoT what is IoT, where it can be used, how it can be used. So I will just show you the video. So I'm just sharing the screen. Okay. Just a minute. I'm just sharing the screen. So I hope now you guys can see the screen, correct? Okay.
Yes, yes.
Okay. Yes. Okay. Is can you guys hear the voice of this video or just a visual?
Yeah,
Yes,
getting
sir, we
voice.
can hear it.
Okay. Yeah. Thank you.
If possible, please increase the volume.
Sorry.
Please increase the volume. Volume
Okay,
of the
the volume
video.
is maximum. It is set to 100. So I don't know if it is possible to increase more
You
than.
can use a control and upward arrow. It can. Yeah, yeah, correct.
Okay. So in this video, it is just showing how IoT can be used. Okay. this is a video. Actually, this is in the first session, but sir already talked about IIoT, industrial IoT, correct? So this video is basically for industrial IoT, that how IoT can be used in industry and how much it is being used. Actually, this video is very old, so that the value that currently shown in in this video, it is very old value. So I won't say that this is the accurate value, but the application that it is shown in this video is still not available in our country, correct? So this kind of application, it is like we should have this kind of application of IoT in our city, in our country, in our state. I can say that. So this is basically the application of IoT for industry, and there is another video that I wanted to show you that is for uh, IoT application for home automation. So I'm going to play another video. So that was the video, and as you can see, there are so many different type of sensors and modules have been used in those videos. Like in first video, the first part was like a medical application. The patient heartbeat detected, which is value is very high compared to the required value. Then the notification will be sent to doctor, and the doctor will initiate the process. The same way in the second video, you guys see that the person will be detected and the uh, related task to the specific person will execute it. Correct? So this is how we can use IoT in many ways. So I know that you guys are hearing related to IoT from the morning, but I will again start from the not from the scratch, but I will give you a brief intro to the IoT. So you guys are aware of what exactly the IoT is. I won't follow agenda. So I will directly start. What is IoT and everything? So as you guys know that IoT is Internet of Things. Things are like any microcontroller, any device which can directly or indirectly can connect to microcontroller. Sorry, Internet. So this kind of devices can be used as a things in IoT. And basically, what exactly happening when we are considering things? Things are basically uh, things include sensors, actuators, and the microcontrollers. So the sensor will read the data, send to the microcontroller, and that data will be sent to the cloud or some gateway or any other particular place. Same way, we can use actuator to send data to microcontroller. So basically, what kind of data it is sending to microcontroller? Like sensor is sending some data which will be digital format or analog format. Okay, so this kind of data is considered as a little data because microcontroller is sending data because there are restriction in resources. Like if you consider microcontroller and computer, that then you can see that in processor you can have much more higher memory, internal flash, or you can consider hard drive. Where compared to the microcontroller, you can see in microcontroller there is a very low space of RAM and also the flash, and you can consider the frequency on in which frequency the microcontroller is running. Like if you consider, Nitin sir already showed shown you the STM, sorry, that Cortex M4 based microcontroller and Cortex M3 based microcontrollers. So Cortex M3 based microcontroller uh, runs on 100 megahertz, and the Cortex M4 microcontroller runs on 168 megahertz. So you can see that very low frequencies there compared to the microprocessor. So basically, for that the data size should be small. That is why you can see on the screen it shows that small data. So here you can see little data. Sorry. You can see little data. So little data is much more related to the things. And here, this is the protocol. You can see there are different type of protocol being used in IoT. So as Bhatt sir also told you that there is a MQTT protocol, there is CoAP protocol, there is also wireless HAP protocol. So these kind of protocols and IP stacks being used in IoT in this area, so that it can transfer the data to the web and you can say the cloud. So on that side, on the cloud side, or you can say server side, the data will get big because the data processed, the data sent from the things, it will convert it at the in IoT gateway, and that data will be sent to the you can say the server. So the size of the data will increase, and you can say that the multiple things are sending data to a specific cloud. So the data size or data space will require higher. So that is why on the server side it is a big data. So this is what IoT structure look like. In the next slide, I'm saying the same thing, but as you can see, there is two names. One is M2M and second is IoT. You guys, if anyone have any doubts, you can just tell me. So you don't require to wait for the end of the session. You can stop me anytime so that I can answer you on that particular time, and other people will also know that what is the new thing, or they might also know that what solution you for that answer for that questions. Okay, so here you can see there are two names. One is M2M and second one is IoT. So basically, initially when the IoT was uh, uh, what can I say? The IoT was uh, came into picture into the market. So before that, industries people they are using this kind of service, but that is called M2M. Initially, it is called M2M, which is called machine to machine communication. So after the use of internet increased and the invention of as you can see in the REST. This is the REST API. The invention of the REST API. So the communication from the embedded hardware to the you can say internet or cloud side communication is possible because of the REST protocol. So from that point, that point, the IoT, the internet came into picture, and the name changed from M2M to IoT, and this is how the IoT was invented. And you can see initially M2M was something like this, because you can see each and every there were no standards. As you can see, are you guys aware of some protocols which is used in microcontrollers like UART? Are you guys aware of this kind of protocol? Hello.
Yes, sir. Yes, sir. We are aware of.
Okay, so basically UART is communication protocol. So the same way, UART is a standard. So each and every company, even if you include Intel or Nvidia or AMD, they are all following the specific standard uh, for the UART. So same way, initially there was no standard. So each and every company, they are using their own method to communicate, to create the communication, to create the to access the machine. Like this, you can see the car, you can see the another application, person and house. So they are using their own protocol, they are using their own method to communicate between to communicate or access the specific device. Then after invention of the REST protocol and internet get popular, uh, then people started to standardize the method how to access the devices, so that each and every company can use the product from different companies, so that they don't have to invent another method. So this is how the internet of things, IoT, got standardized. So, and because of internet, the direct communication, it is replaced with the web. Web is nothing but, you can consider that a specific interface, like HMI display. You can see in the on airport or in the ATM service. So that is called HMI display. So this kind of service, but we are accessing that display, that interface, or via internet. That is the only difference. Otherwise, the things are same. The only difference is this, because of internet, the web. Then comes the why it is become this much popular. The thing is, initially, if you guys are aware of, 8051 microcontroller or 8085 processor. The size of processor, the microcontroller, and the price, you can compare the price and size of microcontroller of current time and the previous time, around you can say around 2000 and 2001 this time. So the uh, size is also bigger and price is also high. So initial, and there is also no internet. So initially, implementing IoT was quite difficult. But if you consider the current time, so you can see the size of microcontroller. See, this microcontroller can work much faster than the 8051 microcontroller. Even the size is very small. Also, it can support much more protocol compared to the 8051 microcontroller. So size got smaller, the price got cheaper, and the internet facilities available. There are so many resources, though so many OEMs are available. They develop microcontrollers. So because of that, the internet can be possible. IoT can be possible because of that. So this is the reason why the internet is IoT is using microcontrollers instead of microprocessors. And now currently the most popular microcontroller is M0 or M0 plus, you can say. ARM technology, they are developing microcontroller specifically for IoT platforms. So Cortex M0 plus or M0, the architecture is basically used for Internet of Things. That is why I have considered this microcontroller for this for the introduction, or you can say for the IoT purpose. But in our case, we are using M4, because on that time M0 was not available. So the architecture which is available was Cortex M3 and Cortex M4. See, these both are microcontrollers. The size is little bit bigger than this microcontroller, but still it can, for the educational purpose, or you can say for the study purpose, you can use this kind of microcontrollers. And even instead of using the Cortex microcontroller that already Nitin sir showed you, you can use Node MCU, which includes Wi-Fi inbuilt in that particular microcontroller. So you don't need to you don't require to interface external Wi-Fi module like usually people do with the Arduino microcontroller. So Node MCU is far better compared to Arduino microcontroller in that part. But instead of using this kind of microcontroller, we suggest you should go for this kind of microcontroller, because if you want to make application, you can go for Node MCU or any other microcontroller. But when it comes to the study, when you want to learn how IoT works, what kind of protocol being used, what kind of driver they are using, if you want to make your own driver, so this kind of flexibility you will only get in this kind of microcontrollers. Like you can even use, if there is a microcontroller which uses M0 or M0 plus, then you can go for that. You can even use Cortex M3 and M4. So these are the architecture that can be used to learn how IoT works. So I suggest you go for this microcontroller instead of Arduino or Node MCU. When it comes to the application, then you can switch to Node MCU or Arduino. Okay. So this is the reason why the IoT it got much more popular compared to the previous, like 10 years up before. And these are the as I told you that M2M was there, but there is no standard. Then after companies started to make their own standard and publish on the internet. So this is one of the IoT architecture, one of the standard which is developed by Open Mobile Alliance (OMA). So they are providing a standard. How should IoT work? What kind of protocol being used? Because there is also security is a bigger concern because if our system, if we are making home automation and someone hack into our home, then they can easily operate any device which is available in your home. So the security is also bigger concern. So considering all those parameters, the different companies, they are started making a standard which can be used for IoT. So as you can see here, there is a section here. I will divide it. So the literal data endpoint can be any embedded device or any applications, any appliances which can be used. As you can see, there are multiple protocols here. You can see one is OMA, low power M2M communication, that is protocol which is developed by OMA. Then after the QoF, which is very popular protocol being used in IoT in current architecture of IoT. Then come HTTP. As you know that HTTP is being used for browsing and for website, correct? And the last part is TLS, which is for security. Okay. Then the second part, as you can see, there is a server. So basically, what happened when we send data from our things, or you can say embedded devices, the data will be sent to the server, and at the server point, or you can say in this case of they are using server, but in our case we are using gateway. So on the server, they will use security, so the data will be secured. It won't get hacked easily. Then after the communication, so using from the server, you can access our embedded system on our PC, in mobiles. Okay, so different using different devices, we can access our embedded systems in our or can say things of IoT. And the discovery. Basically, discovery when it comes, and as you see the second video. The second video, the persons automatically detected at particular location when those two persons on the bicycles, they came into the specific area, they got discovered, and that discovered value, that particular thing will updated on the server. So it says that this person is detected, but actually it is not like that person is detected. It detects the hardware, the things like embedded system, embedded device, which is discovered and updated their data on that server. So this is also called a service which can be used for application. So this is the server part. So till now you can see the data size is little data. Okay, so the data is sent from the embedded device to the server. Then after behind the server, you can say backend. In the backend, you can see the data sent by the embedded device that can be stored or analyzed. It can be used for machine learning also. That data there is multiple data coming from multiple things. So management is also required, and you can use that data in some way or other way for the application. So that is why in this section it is called big data. Okay. So this is also a very old slide. I can say, as you can see, initially it was something like this. Like as I told you earlier, there was no internet. So initially it was M2M mobile technology, like services, internet broadband was there, but speed is very low. Like in 2004-5, you can see that our internet speed was like 1 kbps to 16 kbps, not more than that. So on that time, it is not possible to use internet internet everywhere. So it was very limited, but now the things is changed. So we can use internet in many ways. There were no like interfacing sensors. There are multiple type of sensors are there. Actuators are there. Uh, you can create using those sensors and actuators. You can create smart things. Like you can see currently you will find that smart AC is there, smart refrigerator is there, smart light bulbs are there. Uh, so these kind of devices are possible using current IoT architecture or current technology. Then comes the different standards. So as you can see, there are multiple standards available for the communication, and most popular standard which is being used is this keep this word 6LoWPAN. Basically, you guys are aware of IPv4 and IPv6, correct? So IPv4, there you can connect only limited number of devices using the IP address which is generated using IPv4 technology. But if we consider IPv6, then we can connect multiple device. Even we can't count how many devices we can connect using IPv6 in the same network. So the restriction of IPv4 can be removed or can be removed using IPv6. And using IPv6, we can create a low power uh, network which is called 6LoWPAN. And using the 6LoWPAN, there are many wireless devices and many wired devices being used, so that even industries are using this protocol. And as you can see on the website, and the second point on the website, there is a REST protocol. REST is very security. I can say it is security-less protocol. So to make it secure, the alliance created some modified the REST protocol with the some security. That then after it is called CoAP. So right now, instead of using REST protocol directly, people are using CoAP protocol, so that communication between the IoT gateway, or you can say IoT gateway to the cloud, or you can say our embedded device to the cloud can be possible using the CoAP protocol. Then after there is Zigbee. Zigbee is also there. So in the second video, you saw that there are multiple devices connected wirelessly in the same network. So that it is possible using Zigbee, because Zigbee supports mesh networking that can be used for this kind of services. This kind of application can be possible using Zigbee. And Zigbee also supports IP stack, which is 6LoWPAN, as you can see. So these are the different protocols that are being used in our IoT network. But in industry, they are using another protocol which is called LoRa, which is a low range protocol. Because as you know that in industry, their production facility is somewhere outside the city, and their offices are inside the city. So how to remotely monitor their production environment, so they wirelessly. So they are using LoRa protocol, so that they can wirelessly send the data from that from their production unit or production facility to their offices, so that they can access or they can monitor their devices, which is outside the city, or you can say the outside their particular area. Because LoRa supports communication between device. The distance can be up to 10 kilometers. So it is possible that they are using LoRa. So LoRa is also very popular protocol which is used in industrial IoT. If you search on Google, you will find that LoRa being used in many places currently. So these are the standardization that they are using. Now next come to the why the little data and big data. So initially, as you can see, when we consider our IP stack, so IP stacks the size is like in thousands of bytes, as you can see here. Okay, so if you consider our computer, which runs in gigabyte, correct? So to send the data, to process the data, it won't take much time to process this kind of size, thousands of bytes, correct? But when it comes to the microcontroller, the frequency, the clock in the microcontroller is very low compared to the our processor, our computer. So for that they need, if they want to process this data, it is possible they can process the data, but it will take much more time. So when it comes to the IoT, the power management is also a big part. So people can use it wirelessly on battery, because if you guys are aware of Scilab company, they have developed Cortex ARM based microcontroller which runs on a button cell, which is basically used on our motherboard for the on date and time setting purpose, and they can run on that button cell up to 2 to 3 years. So you won't require external power supply. So this is how the and those kind of kit is mainly developed for the IoT applications. So to use this kind of facility, the data size that a microcontroller can send, which it should be reduced. So as you can see, the uh, specifically designed for IoT, they have compressed the size of 1000 byte to tens of bytes, as you can see here. So this kind of data can be sent very fast, and it can process the data, and you can see not in real time, but after some delay, the data can be processed on server and the action can be taken. So this is the main thing that IoT nodes required. And if you guys are aware of, there is IP stack specifically designed for microcontroller, which is called low power IP, LWIP, which is specifically designed, developed for microcontrollers. Then after, our next slide will be about the protocol. As I told you that CoAP, the Constraint Application Protocol, CoAP nothing but basically a secure REST protocol. So normally when we consider our network, so when we consider TCP/IP protocol, then there is a server and there will be multiple clients, correct? And each and every client can connect to another client via server. It can communicate via server. And here you can see, when we are using REST protocol, these are our things, and which is in a constrained environment, because our device can be anywhere in the in any area, or you can say anywhere. But I mean, in like you can use it in desert, you can use it in jungle, you can use it in home. So it can be anywhere, and there will be always some limitation because of the area in which it is being used. So the data should be small, as I showed you earlier, and this is our CoAP based things, or I can say embedded device. So basically, how it can use to communicate with our current network. When microcontroller uses CoAP kind of protocol, but it can not directly communicate with our PC, or you can say our web server or cloud, because they are using TCP protocol and CoAP is different protocol, so they might not able to communicate directly. So that is why there comes the proxy. Proxy is nothing but you can consider it is a gateway, and application of gateway is translation of the you can say data. So in our case, in the solution that we provide in our IoT, we are using Raspberry Pi 3 as our gateway. So basically, what we are doing in our case, this area will be replaced with our microcontrollers, which uses UART as a non-internet or you can say like that kind of protocol. Then comes the Ethernet, then comes the Wi-Fi, then comes Bluetooth, uh, then comes the Zigbee, XB, sorry, Zigbee. So as you can see, there are multiple protocols which our hardware supports. But how can it understand the language of internet on the server side? How it can communicate? So for that, we are using Raspberry Pi here, which receive data in the serial communication way. Like in the UART data will be received on our proxy, and it will be translated on our gateway, and data will be sent to our server. Same way Ethernet data, for Ethernet, we can directly use TCP protocol, but as you know, as I already told you, that TCP protocol comes with bigger size of packet. Okay, so here we are using different protocol, and the communication method to make it secure, we are using a technology called MQTT. I will explain in detail later. So this packet will be sent to the Raspberry Pi, and it will be translated over here and will be sent to our server. Same way there is a Wi-Fi also. Bluetooth also uses UART communication protocol. Then comes the Zigbee. Zigbee has its own protocol for communication between Zigbee module, but to communicate with microcontroller or embedded device, it uses I2C protocol or UART protocol. So this kind of protocol will be sent to uh, our IoT gateway. Then the translation will happen, and data will be sent to server. So this is how the architecture works of IoT, and the most part is our gateway. But as you can see on this section, let me clear this screen. So here there is a device which can directly connect to the server. There is a client which can directly use the HTTP protocol and can connect to the server. So if the server has facility of using CoAP protocol, then that server can the data can be directly sent to the from the microcontroller or embedded system to the server. The same way, if the microcontroller or embedded device supports HTTP protocol or any other protocol which supports the server, then that data can be directly sent to the server. As you can see, there are different clients here. So, if I want to explain, sorry, if I want to explain in a different way, then I can say, let's take an example. So Nitin sir already told you about the NVIDIA-based GPU computing kit, correct? So that kit supports HTTP protocol. It also supports CoAP. It also supports REST protocol, because the system which is running on that hardware is Ubuntu operating system, and Ubuntu and operating system supports many different protocols. And if the protocol is not there, if the library is not there, we can add manually. So that kind of device can directly send data like this to the server. And if you consider what kind of servers are there, so basically, if you consider the IBM, then their Bluemix is there. If you consider AT&T, then there is a M2X server they are using for the cloud computing. If you go for if you search on Google, you will find many different server like Blinky and like things, something like that. There are many different servers are available. So to communicate with this kind of server, you can directly use their communication method. They are providing the library. Just add those library with your program, and you can directly communicate with their servers like this. But in our case, we are using IoT gateway. So our each and every data will be translated over here, and then after it will be sent to the server. So this is our IoT structure that we are going to use. Okay, and here you can see this is the actual model which is developed by Freescale Technology. Currently, Freescale name owned by NXP, I think. So this is the architecture of Freescale. They have developed their own architecture, and you can find this kind of kits. They also support IoT. So these are the embedded device, as you can see here. This kit, this is also a kit. So this kind of embedded device, and you can see here they are also using gateway. They are also using gateway to translate their data, because as you can see here, they are using low power M2M CoAP, low power M2M and CoAP for communicating their embedded device to the gateway, and then after you can see the translation, it will eDTLS. So this kind of communication will be done, and the data will be sent to the server, and the data will be processed at the backend, as you can see here. So this is another architecture of IoT that is currently used in this kind of company. And now comes the protocol, this application. Like you can see a simple application. So as I already told you in our first video, we saw that medical application. So the device has internet connectivity using Ethernet connector. So in this area, you can consider this as a GSM, or in currently LTE, you can say LTE. So using this different protocol, the data will be sent to the cloud, and you can access in your computer browser or a tablet or mobile phone. So these are different application of our Internet of Things. And if you want to divide this three part, so if you want to divide, so it will be something like this. This one is like connect, then after this here in the cloud, it will be managed, and here you can visualize. So it will be something like this. First part is connect, because our sensors and actuators are connected to our embedded system. It will send data via Ethernet or any other protocol like Wi-Fi or GSM. Data will be sent to the cloud. So on the cloud, we have to manage data, analyze the data. You can even process the data, and you can use that processed data to visualize what exactly happening there. You can even trigger some service, like in our first video we show that that person blood pressure, heart rate increased, so that it will trigger the service, like it inform the doctor that this person's heart rate is increased, so we have to take action. So this kind of action can be taken using the analyzing the data. Okay, so next, this is the MQTT that we will talk about, because MQTT in our current IoT setup, we are using MQTT protocol between our embedded device to our IoT gateway. So basically, these are our things, and this is our IoT gateway. Raspberry 3, and here it can be M4 or M3. So why I am explaining MQTT protocol? MQTT protocol basically initially developed by Facebook. They are in the Messenger facility, because as you know, Messenger is used in our mobile phones, but it is available for very long time. But as you know, that data from the embedded device to send to their server, it requires security and also the size of the packet, which should be less. So they have developed a specific protocol which is called MQTT, and they uses this kind of method to communicate between two users. As you can see, there is one user is one thing is this our kettle, and the second thing is our hardware where we can visualize the data. So basically, same as our TCP/IP protocol, like communication between client and server. Instead of server, in MQTT language, it is called broker. As you can see, this is the broker. So basically, when we want to communicate with another thing or another or visualize our data, then we have to uh, subscribe the data. As you can see here, the data will be sent in some this kind of format, and data will be received on broker. And the same time, the our visualized device is subscribed to this particular channel so that it can receive data from kettle on this on this mobile phone. And the same time, the data will be sent on our on our phone or any device where we can visualize. So these are the feature of MQTT. This is how MQTT is used. And this, if you have any query regarding this particular part, like protocol, any protocol or any query regarding the IoT, the architecture part, you can ask me right now. So that after that, I will just give you brief introduction of the hardware that we are going to use in our IoT.
Any queries, participant?
Hello.
Yes, sir.
Good evening, sir.
Good evening.
This is Neeraj from Raisoni College Institute, Nagpur. Actually,
Okay.
sir, I have been working in the field of embedded system and robotics for quite a long time, and I found one issue while using this Arduino development board, that it does not support the real-time troubleshooting of high sampling rate sensor data. So how to avoid it, and what are the cheap solutions to overcome this problem?
Okay, so basically, if you consider the Arduino, then Arduino is very low power and it works at very low frequency. So if you want to process a high frequency data, high signal data, then you require first you have to change your microcontroller, which can process that fast. So you have to first check which microcontroller you can use, which is much more compatible with your sensor. So that will be your first point. Then after if it is compatible with your sensor, then you just have to uh, check that which if it is supported this if any protocol that is being used in IoT. That will be your second point. And if it is supported, then you can go for implementation. Like if you consider uh, I can say yes, Node MCU. Then Node MCU supports Wi-Fi, correct? So you can use Wi-Fi for the data transmission from your micro embedded system to the cloud, or you can say your server. The same way, but uh, at the same time, the Node MCU's the frequency that in which it is processed the data, which is very low. So the sampling rate you will find for your sensor is will be not compatible with your microcontroller. So you have to go for another microcontroller. Like suppose we are using Cortex M3 or M4 based microcontroller, which is LPC1768, which is Cortex M3, and STM32 F4, which is Cortex M4. So they supports a little bit higher frequency and it sampling rate, so you can interface this kind of sensor. And this both both microcontroller supports Ethernet. So Ethernet will be on board, so you can use this kind of microcontrollers. Same way, if you consider wireless interface, like Bluetooth or Wi-Fi or Zigbee to transmit the data to your uh, my embedded system to the gateway, then it is also supported by the microcontroller, because if you see the UART, then UART works on baud rate. So the baud rate supported by the microcontroller, which is around 2 kbps. So that can be used for the processing the data. So you just have to go for another microcontroller, you just have to change your view. So you will find a solution.
Thank you very much, sir. But still a little doubt I want to clear. So I am talking about the data transfer rate at GPIO. So the pins which from where we are actually collecting the data. I am not talking about the sample rate of the communication like UART and
Okay,
UDP
but
protocol.
if you consider GPI is also on GPI, you will find in the data sheet that it also requires sampling rate, because the when you start the microcontroller, there will be a initial state of microcontroller, like the GPI will be considered as a input state or output state, how much current it can consume, what is the sampling rate, I mean what is the frequency of changing the value from in or out. So there will be something that can be used to read the data, because I think you are using GPIO and putting the GPIO in mode and out mode, correct?
Yes, 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 sir.
Yeah. So there will be some frequency, because when you consider coding, so the in the programming you will see that processing the program, like so consider GPIO, that if you consider GPIO, then executing the GPIO from input state to output state, it will take some time. So there will be some delay. Plus the microcontroller, the processing speed of that task, that changing transaction, that will be also added. So for considering that all things, there will be some sampling rate from using that particular value. You can consider that this microcontroller is supported or not. So you just have to refer the data sheet and see that what is the sampling rate, or I can say the frequency from which it can change from value high to low, or so in to out. So this is how you can check it out, which microcontroller is supported or not.
Thank you very much, sir.
Okay.
Hello,
Yes.
Bhavin sir, thank you for your very, very informative and interesting session.
Okay. Thank you.
In fact, I am not from computer and IT background, from mechanical background, but still I'm trying to learn many things and understood very well basics of the IoT. My query is regarding sir, tomorrow's session. We have a whole day hands-on sessions.
Yeah.
So I hope for a person like me who does not have a computer IT background, even electronics background. So I hope it will be okay for us as well.
Yeah, you will. In our current session, are you able to understand what exactly I'm saying, or kind of things? Did you get anything of what I was trying to say?
Yes, yes, yes. I am following, sir.
So I will try. I will make sure that you will understand in very basic, in very simple language. I will try to explain each and everything in very simple language, so that anybody can understand. So you don't have to worry about that.
Okay,
Okay.
thank you.
Actually, we have many examples, but our session period will be very short, so I am not able to demonstrate each and every example. But I have considered the example. I have created example list that I will going to show you tomorrow. So you will understand how the IoT works, which different protocol we are using. So I will try to make sure that you guys are able to understand, and I will try to make it as much as interactive as possible, because in our tomorrow session, like I want you guys to access the device which is currently set up here, and you will see the change. Like you are controlling lights, controlling relay. You will able to read the data of that microcontroller on your own PC. You just have to log into a particular cloud. So I will try to make it as much as possible. Try to make it interactive as much as possible.
Okay, thank you, sir.
Yeah. Any other queries? Hello.
Yes, sir. So I don't think that there are any further queries. So we will pause for a day here. And thank you very much, Bhavin sir, for today's informative session.
Okay. Thank you, sir.
Yes, all the participants are requested to join tomorrow's session with the given link. Thank you very much all. We will call for a day here. Thank you all.